Hello everyone, in this tutorial I want to show you how to design a parametric ceiling like this. So first of all, we go to the Rhino and draw a box as a space that we want to design and put it to the shaded viewports. And after that we select these two surfaces. So I type extract surfaces and then select these two surfaces and press enter. And after that we move this surface to see inside the space. As you know, in Rhino, if you want to manipulate and change the form of the surface, you have to put the contour point on and then manipulate. So I select this surface and press F10, and you can see we have 4 points, 4 contour points, and we can move it up or downward. But as you can see, we have inadequate control points, so we cannot change as much as possible that we want. So it's better uh, to increase the control points. So I select the surface and then type rebuild. Here we can see we have U and V, and inside the parentheses you can see 2. It means that we have 2 control points in U directions and 2 control points in V directions. But we want to change it and increase it to, for example, 10 as a default. Is not bad, and then press OK. So if again I select the surface and press F10, you can see we have a lot of control points that now we can manipulate, and we can deform the surface better. So it's better to put it in a wireframe again to select the contour point easily. So here, for example, we choose these contour points and then put it downward. And again, for this part, for example, we select this one and put it downward again. And for this part, these 5 and put it downward, not a lot. Okay, you can manipulate as you wish, but I think not bad here. Now we change and deform the surface that we wanted. So after that we have to import the surface into the grasshopper. So I double click on canvas and type surface. You can see here surface, and then it's better to see the name of the component. So right click on the surface and select one surface and then OK. We can internalize the surface, so I right click on the surface and choose internalize data. It means that we can delete it here and we don't need anymore. So after that we want to divide the surface into many surfaces. So the component that we can help us here is isotrim. As you can see, the isotrim has 2 inputs. The first one is surface. It means that which surface you want to divide. So I connect the surface to the surface, and for domain we have to use divide domain to. It means that we should connect the divide domain to the domain and then connect the surface to this domain. So we can see we divided the surface, but as you can see, this surface, the initial surface and the divided surface are overlapped together. So I choose the surface and press Ctrl Q, not to see it in. It means that we disable the preview. And here we can change the U and V directions. For example, here we have U, and we have 10 in U and 10 in V, so we can change it, for example, to 24 for U and 24 for V, or maybe we can have it 25 for V. That's enough, because if we have a lot of surfaces it should be slow. So after that we want to scale these surfaces. The component that we can do this for us is scale, of course. As you can see, scales have three inputs. The first one is a geometry that we want to scale. So we want to scale these 250 surfaces. So we connect the surface to the geometry. But as you can see, the place of these surfaces are not correct. We want to scale each surfaces at the same place. So we use a component called area and connect the surface to the area. As you can see, the area has two outputs. The first one is area. It means that we can find the area of each surfaces. And the second one is centroid. It means that the center of the surface here in this project. So I connect the centroid to the center, and you can see we have the surface at the correct place. But again, I select the isotrim and press Ctrl Q not to say this. And the last input is factors. It means that it is the size of the scale. So for example, I choose it 0.4, or we can change it if we want. So it is not bad, but I think it's better to increase the amount of this. For example, 50 for this one, and 40 for the U count to increase this one. And it is better again to change it to, for example, 0.6. I think it's not bad. So the next part, we want to extrude these surfaces downward. So I double click on canvas and type extrude. You can see the extrude has two inputs. The first one is the object and geometry that we want to extrude. So we connect the geometry to the base. And the other input is a direction. It means that in which direction we want to extrude. Of course, we want to extrude in Z directions. And we have to connect the Z direction toward the this direction in extrude. So, the amount of the extrusion is defined here with vector. For example, 10.36. We can change if we want. So we'll connect this one to the unit Z and then connect to the directions. We wait a minute because we have a lot of surfaces. It's a little slow, but as you can see, we wanted to extrude it downward, but now it's extruded upward. So we can change it here. We right click on the directions, and in expression we type -x. It means that the input should be inversed. So we commit the change and you can see the change. Again, we wait a minute. So it is true. Now you can see it inside the space. Is better to is it like this pictures? It's better to bake the last geometry. So I bake it to the default layer, and then okay, and then we disable the preview. It's better to put it here in a render view form. Now is a parametric ceiling. You can see a parametric ceiling. It is like these ceilings. You can change the size of the boxes. I mean these boxes that are hanging from the ceiling, and you can increase or decrease the amount of the boxes too. So that's a wrap. I hope you enjoy. If you have any comments, you can drop a line behind the video. Thank you. Bye for now.